Hi there, Emma. We scared you away one day with your birthday, and that was enough. So we hope you had a great time. Here's our lesson on sequences. I'm going to first show you how to generate a sequence. So here you have a sub n is equal to n minus 5. And so this terminology means if we plug in a 1 for n, that's a sub 1, meaning the first term of the sequence. And that's equal to 1 minus 5, or negative 4. So that's the first term. Whereas the second term is going to be equal to, anybody want to guess? 2 minus 5, which is negative 3. A sub 3 is 3 minus 5, or negative 2. And a sub 4 would be negative 1. Do you see the pattern that's developing? Could you look at those numbers and predict the fifth term, the sixth term, seventh term? Good. What's nice about this formula is it is explicit, meaning that we can plug in a term number and it will generate that term for us. So the 100th term will be equal to 95. Not all sequences are like that. Next one's a little bit more complicated. A sub 1, a sub 2, a sub 3, a sub 4. These are our term numbers. So the first term would be equal to 3 times 1 plus 1 squared. Anybody? 4. 2 times 3 plus 2 squared. 10. 3 times 3 plus 3 squared. And 3 times 4 plus 4 squared. 28. There we have it. Could you predict the next term? What is it? 40. How'd you get 40? What's the pattern that you're seeing develop? Plus 6, plus 8, plus 10. So now you're going to do plus 12. Is that correct? Okay. So, you see a pattern developing here, right? And sequences have those patterns. Look at the previous one. You went up by 1, 1, 1, right? You went up by 1 every time. What degree is this equation? What power do we have? First power. Look at this one. The first set of differences is not the same, but if you look at the second set of differences, it is the same. And what degree is this? 2. Interesting, huh? So that kind of shows you how some of these quadratics and linear equations are developed. That's what we have there. We get rid of that, and we go to a sub 100 would then be equal to 300 plus 10,000. And I get 10,300. What do you think? Look at the next one. A sub 1, a sub 2, a sub 3, a sub 4. If I plug in 1, what do you get? 3 over 5. If I plug in 2, what do you get? I get 1. If I plug in 3, what do I get? 9 over 7. Plug in 4, what do you get? 12 over 8, which is 3 halves. So do you feel like you could look at that and predict the next number just by looking at it? So the first couple examples we looked at, you're like, well, it's easy to figure out the next term. Sometimes looking at terms is very, very complicated. Very complicated. What's that? Is it? So we got this guy here at, let's see, so 6 over 6, you got 9 over 7, you got 12 over 8. So you write it like that, and as you say, you go 3 more up on the top as you're doing 3 up on the top. You do 1 more on the bottom, right? Yeah. So So you can see when you write it in different fractional form, a little bit easier to see, right? But some sequences are super difficult to go from one step to the other, and trying to figure out, it's one thing to be able to generate the terms. It's a whole nother thing to be able to take and bring it back to the formula. One of the last college classes I took, advanced combinatorics, we had to take some of these sequences and put them into this type of form. And remember one of them I did, it took about 10 hours, about 6 pages of paper, and you just kind of hoped you got it right. A lot of work along the way, but very powerful stuff. We're not going to get into real in-depth pieces, but we're going to look at some of the basics. Let's look at this one. A sub 1, A sub 2, A sub 3, A sub 4. If I plug in 1, what do you get? 2 to the negative 1, which is 1/2. Whoop, I put the negative there. Slip of the brain. If I plug in 2, 2 to the 0, 1. If I plug in 3, get 2. If I plug in 4, I get 4. Can you tell what's happening each time there? Just doubling, right? You're multiplying each one by 2. So it'd be easy to say next term is 8, then 16, then 32, so on and so forth. So the A sub 100th term would simply be just 2 to the 98th power. And we're not going to expand it out. We'll just write as 2 to the 98th because that'll be a lot of work, right? I mean, that'd be a big number. Like, I don't even know if your calculator, what it does. It says, hey, stop. It's too big of a number. I'm confused now. Okay, 3.1 times 10 to the 29th power approximately. Cool. Thank you. All right, we're going to skip F, but we're going to do E. A to the 1, A to the 2, A to the 3, A to the 4, and we'll do A to the 100th. Notice you have this negative 1 to the nth sitting in there. So that means that we take negative 1 and we raise it to the term number that we're seeking. So if you have negative 1 to an odd power, what are you going to get? Negative 1. If you have negative 1 to an even power, what are you going to get? Positive 1. So if you plug in 1, we have 4 times 1, which is 4. Is it going to be plus 1 or minus 1? So I get 3. And then it's going to be 4 times 2 is 8, and will be plus 1 or minus 1. Plus 1 to get 9. 4 times 3 is 12, will be plus 1 or minus 1. Minus 1 to get 11. And then 4 times 4 is 16, plus 1 or minus 1. Plus 1, I get 17. So that means that the 100th term would be 4 times 100 or 400. And would it be plus 1 or minus 1? Plus 1, so 401. Tennis boys, you guys need to go? Just about. Oh, 45? I thought you said like 35. It's like, wow. Destroy them. Feeling a little bit under the weather? Sorry, Timothy. It's all good. Little cold never hurt anybody, right? All right. So let's start with the most basic type of sequences. I gave you guys some sequences where we generated terms, but now we're going to talk about the types of sequences. The most basic type of sequence is an arithmetic sequence. Arithmetic sequences have terms that have a constant difference. So for example, 3, 5, 7, 9, 11, all those terms go up by 2. They have a constant difference, so that would be arithmetic. You can see how we generate the arithmetic sequence. We take the first term, and then the second term we add a difference. And then the third term we add 2 of those differences. For this term, we add 3 of those differences, so on and so forth. The formula for an arithmetic sequence is a sub n is equal to a sub 1 plus the difference times n minus 1. So what we want to do now is we want to write the rule for the sequence. So it says find the nth term and the 20th term. So a sub n is equal to, first I'm going to write this sequence out. My first term is 5. Can anybody tell me what the second term will be? 8. How about the next term? 11, 14, so on and so forth. So a sub n is 5. That's the first term, plus the difference, which is 3 times n minus 1. Or a sub n is equal to 5 plus 3n minus 3, or 3n plus 2. That will tell me any term number. So we just came up with the equation. So I would like to figure out the 20th term. So I could simply plug in 20, and what do you get? 62. What I would like you to do is letter B on your own. Yep. So there you have, there's letter B. Yeah, do that on a test. It'll be a fun time. YouTube didn't catch my joke there. I didn't think they would think it was very funny, but I wait for that one every year. Right? How that came up is I was in class and I was teaching, and a student was like, wait a minute, is it going to come up as 62 every time? And I couldn't resist. And I was like, yeah, it is. It's like the rule of 72 in economics or whatever. And I said, have you heard of that? They're like, yeah. I said, well, we have a rule of 62 in math. And everybody just started, they're like leaning in, they're nodding. And oh, I just couldn't. Anyway, all right. Yeah. All right, so what's different about this example? Yeah. So what do we have different here? What's different about this one? There's no a. So we know that a sub 1 is -3. That's pretty much straightforward, right? Well, they don't give us the difference, do they? Can we? What is the difference? It's 4. So now we can figure it out. We say that a sub n is equal to -3 plus 4 times n minus 1. He's getting angry. So a sub n is equal to -3 plus 4n minus 4. Or a sub n is equal to 4n minus 7. So if you want to figure out the 20th term, a sub 20 is equal to 80 minus 7, or 73. It is not 62. How about if I taught them that way, then when I wrote the test, they put 62 for everything. I came back and I marked them all wrong, and they were like, got all angry. And I said, well, I was just joking. Didn't you guys catch on? You'd be upset. You couldn't take the joke. You'd be all down and gross. Oh, that's funny. All right. Yeah. Yeah. So what's the difference here? What do we got for a difference on this guy? Yeah, -0.5. So you have to do a -1/2 times n minus 1. So a sub n is equal to 20 minus 1/2 n plus 1/2. I could combine the 20 and the 1/2. I'll find common denominators. 40 over 2 and 1 over 2 make 41 over 2. And those have common denominators already, don't they? I just raised 41 minus n. And that's a nice, easy way to write it, because when you want to find the 20th term, it's easy to plug in 20. A sub 20 is equal to 41 minus 20 is 21. So 21 over 2 is my 20th term. What do you guys think? Not too bad? All right. Thank you for your honesty. Geometric sequences. We have these 6 left to do. They're even easier than the previous ones. Geometric sequences have consecutive terms that have a constant ratio. So we're multiplying by the same number every time. So for example, if I give you the sequence 1, 4, 16, 64, 256, what am I doing to that sequence every time? Multiplying it by 4. 1, 4, 16, 64, 256. So I'm multiplying by 4 every time, okay? So that makes it geometric. So we start with the first term. For the second term, we multiply by a ratio r. The third term, we multiply by the ratio squared, then the ratio cubed, so on and so forth. So our formula is a sub n is equal to a sub 1 times r to the n minus 1 power. So it just says find the nth term. We won't worry about finding the 20th. I'm going to write out the sequence. I have 2 for my first term. Does anybody know what my second term is? 6. What would be the next one? 18, then 54, so on and so forth. So I have a sub n is equal to, it says take the first term, which is 2, and multiply it by, what is the ratio? And raise that to the n minus 1. Can I do 2 times 3 to get 6? Why can't I do that? Because the order of operations say you would have to do the exponent first before you multiply those together. So this one, I have 64 as my first term. What's my second term? 32, then 16, then 8. Good job. You guys are smart. So I have a sub n is equal to the first term, which is 64, times 1/2 raised to the n minus 1 power. That's it. What's different about letter C? Yeah. So what is R? R is 3. So a sub n is equal to the first term, which is 1, times 3 to the n minus 1. That's it. Told you it'd be easy. What's the ratio for this one? Negative 1/4. So a sub n is equal to negative 200 times the quantity, negative 1/4, raised to the n minus 1 power. Letter E, what is the ratio? Root of 3, or r is equal to 3 to the 1/2 power. So I have a sub n is equal to 1 times 3 to the 1/2 raised to the n minus 1. Hey, what do I do when I have a power to a power? I multiply. So a sub n is equal to 3 to the n minus 1 over 2. And finally, one more problem. Can you tell what the ratio is here? Yep, negative 2/3. So a sub n is equal to 8 times negative 2/3 raised to the n minus 1. And there we have it.